Hello, this video is about weight initialization techniques in deep learning or neural networks. So, weight initialization is a crucial aspect in deep learning that can greatly impact the performance of a neural network. If the weights are poorly initialized, they may not converge and may take a really long time to train the model. So in this presentation, we will try to explore the basic weight initialization techniques, uh, which were traditional, and their shortcomings or disadvantages, and then we will move on to the better weight initialization techniques that can be used instead of the traditional methods. So, moving on to the basic weight initialization methods, there are predominantly two weight initialization methods, which are uniform initialization and normal initialization. So, these are the two weight initialization methods that were commonly used. So the uniform initialization initializes the weights randomly from a uniform distribution, while normal initialization initializes the weights from normal distribution. So, however, these methods have several disadvantages or shortcomings, such as vanishing and exploding gradient problem, which can lead to slow convergence and unstable training, or this may take a really long time to train a particular model. So, moving on to the uniform initialization, uh, this is a representation of how we do that in Python language. So, this is done using TensorFlow package. So here, if you can see, the kernel initializer is taken as uniform, and activation function is ReLU. So the next, this example is for normal initialization. So here the weights are initialized using normal distribution. So if you can see, uh, kernel initializer is equal to random normal. So, what are the problems associated with these traditional methods or basic weight initialization methods? So, the only two problems which arised from these basic methods were vanishing gradient problem and exploding gradient problem. So, these were the really known deep learning issues that occurred during the training process. So, where the gradients of loss function with respect to the weights became either too small or too large. If the gradients of the loss function are too small, then vanishing gradient problem arises, and if the gradients of loss function becomes too large with respect to the weights, then exploding gradient problem occurs. So, this may lead to slow convergence of the model, or this can prevent the model from learning the whole stuff. So, basic weight initialization methods such as uniform and normal initialization can contribute to vanishing and exploding gradient problems. So, uniform arises. So the bottom line is the uniform initialization can lead to exploding gradients if the weights are too large, and normal initialization can lead to vanishing gradients if the weights are too small. So, moreover, these basic methods do not take into account the input and output units of each layer, so which can result in weights that are not appropriately scaled. So, for example, a layer with large number of inputs but a small number of output units might require smaller weights to avoid exploding gradient problem, while a layer with smaller number of units but large number of in output units might require larger weights to avoid vanishing gradient problem. So these were some of the shortcomings or disadvantages of the basic weight initialization methods. So as to overcome these shortcomings, there are several better weight initialization methods which have been proposed later. Some of them are Xavier initialization, Lekan initialization, He initialization, and orthogonal initialization. So um, the way in which these better weight initialization methods are different from basic is that these techniques take into account the number of input units and output units of each layer and are designed to prevent the before discussed vanishing problem and exploding gradient problem. So let us explore these techniques one by one. So the first comes is Xavier initialization. So Xavier initialization sets the weight to be uniformly distributed in the range of -1 by square root of n and +1 by square root of n, where n is the number of input nodes or the input units in the input layer. So this method works well with activation functions that have linear region. So the activation functions which have linear function is ReLU. So here is a sample representation of how we work with Xavier initialization in Python. So here, where we initialize the weights, we have taken Glorot uniform. This is Xavier initialization is also termed as or also known as Glorot uniform initialization, and the activation function is chosen as ReLU. So next is He initialization. It is quite similar to Xavier initialization, but is better suited for activation functions that are not necessarily symmetric around ReLU, such as sorry, is around zero, such as ReLU. So here the initialization set the weight to be normally distributed um, with mean 0 and standard deviation square root of 2 by n. Again, here n is the number of input units in the input layer. So here is the representation of initialization in Python. So here the kernel initializer is set to he normal, and activation function is set as ReLU. Then up next is Lacon initialization. It is also known as efficient backprop technique. So this takes into account the size of the input and the output layer also. So this method can be used with activation functions that are not necessarily symmetric around zero. So which can be hyperbolic tangent activation functions. So here is how we can use Laken initialization in Python. So here the kernel initializer is set to Laken normal, and the activation function is taken as tanh. So the next one is orthogonal initialization. So this method initializes the weight matrix with an orthogonal matrix, and this method helps to avoid vanishing and exploding gradient problems that can occur in deep neural networks. So here is a representation of orthogonal initialization in Python. So in this we have to import the orthogonal function or orthogonal method from keras.initializer, which is present in the TensorFlow package, and the activation function here is again ReLU. So, how better weight initialization methods address the shortcomings of basic methods? So, These methods such as Xavier initialization, he initialization, Lincoln, and orthogonal initialization, these address the disadvantages or shortcomings of the basic methods by taking into account the number of input and output layer units of each layer, and by being designed to prevent the vanishing and exploding gradient problem. So there is this one more initialization technique which is effective in overcoming the shortcomings of basic weight initialization methods, which is random ReLU initialization. So it is a method that can be used with ReLU and its variants such as leaky ReLU and ELU. So to improve the performance of deep neural networks. The basic idea behind randomized ReLU initialization is to randomly set a fraction of ReLU units to 0 during initialization. So this encourages the remaining units to learn different features, which can help prevent overfitting of the model and improve the generalization performance of the model. So specifically during initialization, a part of ReLU units are randomly set to 0 with probability p, while the remaining units are initialized with standard ReLU initialization methods such as he initialization. So that the value of p can be tuned to achieve the best performance on the specific task. So the randomized ReLU initialization has been shown to be effective in improving the performance of deep neural networks on variety of tasks, including image classification and object detection. So the conclusion is, um, weight initialization is a critical aspect of deep learning that can have significant impact on performance of a model. So basic weight initialization methods such as random initialization and uniform initialization have some disadvantages such as vanishing gradient problem and exploding gradient problem. However, the better weight initialization methods such as Xavier initialization, he initialization, Lincoln initialization, orthogonal initialization, and the randomized ReLU initialization have been developed to address the problem. And how do these methods overcome these disadvantages? They take into account the number of input units and output units at the each layer of a neural network. So yeah, the this is what I just discussed in the PPT. And by using these better weight initialization methods, deep learning methods can be trained more effectively and efficiently. It is important to consider the specific task and architecture when choosing weight initialization methods, as some methods may work better in some certain tasks or architecture. In general, it is recommended to use one of the better weight initialization methods rather than basic methods for improved performance and stability. Thank you.